In the present video, we will discuss the flowchart scheduling problem. In flowchart scheduling problem, there are n number of jobs. Each requires processing on m number of different machines. The process sequence of all the jobs are same, but the processing time for various jobs on a machine may be different. Let's see the characteristics of flowchart scheduling. First one is a set of multiple operations jobs is available for processing at a time 0, which means each job requires m operations and each operations requires a different machine. Next one is setup times for the operations are sequence independent and are included in processing time. Third one is job descriptions are known in advance. And next one is the m number of different machines are continuously available. And last one is each individual operation of a job is processed till its completion without break. Next we will discuss the Johnson's algorithm. Johnson developed a polynomial algorithm to get optimal solution for two machines and n jobs. So for example, flowchart problem for two machines and n jobs. So in the tabular column, you have to observe there is the jobs 1, 2, 3 up to the n. Similarly, it is having the two machines. One is the M1, another one is the M2. And here T11 is the processing time for the first job and the first machine. T21 is the second job on the first machine. Similarly, Tn1 represents the processing time for the n jobs on first machine. Similarly, here T12 represents the processing time of the first job on the second machine. T22 is the processing time for the second job on the second machine. Similarly, Tn2 is the processing time for the n job on the second machine. So let's see the algorithm. So it is the first step. Let considering the step 0 is the create empty cell in number equal to the number of jobs. So first we have to create the empty cells. The size of the cell is which is equal to the number of jobs. And next step is the find the minimum processing times among the various Ti1 and Ti2. So first we have to observe the minimum processing time for the all the jobs. After next step 2a is the if the minimum processing time requires at machine 1, then you have to place the respected job in the leftmost available position. Then you have to go to the step 3. So first I have to observe the minimum processing times for the all the jobs. If the minimum processing time is for the respected job in the machine 1, then you have to place the respected job in the leftmost available position. Then you have to observe the step 2b. If the minimum processing time requires at machine 2, then place the associate job in the rightmost available position, then go to step 3. Similarly, if the minimum processing time is for the respected job in the machine 2, then you have to place the respected job in the rightmost available position. Next we have to go for the step 3. In the step 2c, we have to discuss about the condition for the tie of the minimum processing time. If minimum processing time required at both M1 and M2, then we have to place the job associated with the M1 in the leftmost cell and allocate the job associated with the M2 in the rightmost cell. So if there is any tie for the processing time, for the M1 machine. Similarly, job respected to the M2 machine. Then you have to place the job respected with the M1 machine in the leftmost cell. Similarly, you have to place the job which is associated with the M2 machine in the rightmost cell. Similarly, there is the another two condition for the tie. First one is the if the equal minimal values occurs only for machine 1. So if the minimum processing times are equal for only machine 1, then we have to select the job with smaller processing time in machine 2 to be placed leftmost vacant cell in the job sequence. Similarly, another condition for the tie is the if the equal minimal values occurs only for machine 2, select the job with smaller processing time in machine 1 to be placed rightmost vacant in the job sequence. And next step 3 is the remove assigned job from consideration and return to the step 1 and 2 until all position in sequence are filled. So this is the Johnson's algorithm. So next we will discuss about the one example problem for the processing n jobs through two machines. Let's see the problem. Find the make span for the following two machine problem. So here there is given the five jobs are given, that is the J1, J2, J3, J4, J5, and there is given the two machines, machine 1 and machine 2. So respected problem is belongs to the processing n jobs through two machines. So let's see the solution. So first one we have to create the empty cells in number equal to the number of jobs. So here number of jobs are the 5, then empty cell size also should be the 5. And next step is if the minimum processing time requires at machine 1, then place the respected job in the leftmost available position. Similarly, if the minimum processing time at the machine 2, then you have to place the respected job in the rightmost available position. So next we have to go for the job sequencing. First we have to observe the processing time for the all the jobs. Here observe minimum processing time is the 5. So 5 is the minimum processing time among all the processing times which is related to the job 5 on machine 2. Then we have to allocate the job 5 on rightmost vacant cell. So then we have to remove the job 5 from the consideration. So next we have to observe the processing times for the all the jobs except the job 5. Here 6 is the next to minimum processing time among the all the processing times which is related to the job 1 on machine 2 and also J2 on machine 1. So here next to minimum processing time is the 6, that is for the job 1 on the machine 2. Similarly, job 2 on the machine 1. So it is the tie condition, but tie is occurring for the different machines. So in these conditions, we have to allocate the J1 in the rightmost vacant cell because J1 is occurring for the machine 2. So how we have to allocate the job 1 in the rightmost vacant cell and allocate the job 2 in the leftmost vacant cell because J2 is for the belongs to the machine 1. Then we have to remove the job 1 and job 2 for the next considerations. Next minimum processing time is the 8 for the job 3 and job 4 on the same machine M1. So here observe next minimum processing time is the 8 for the job 3 and job 4 on the same machine, that is the machine 1. So this is the tie for the processing time on the same machine. So in this condition, if the equal minimum values occur only for machine 1, then you have to select the job which having the smaller processing time in machine 2, that is you have to place the leftmost vacant in the job sequence. So here 9 is the minimum processing time for the machine 2 for the job 3 and job 4. So 9 is belongs to the job 3. So then we have to allocate the job 3 in the leftmost vacant cell. Then similarly we have to allocate the job 4 in the leftmost vacant cell. So there is the only one cell and one job. Obviously have to place the at the vacant cell. So this is the job sequence. After that we have to remove the J3 and J4. So here, so total jobs are filled in the job sequence. Then we have to go for the calculation of the time span. Next we have to calculate the time span or total completion time for the job sequence of J2, J3, J4, J1, J5. So for this one, first we have to write down the tabular column. First column which is consisting of the job. Next column machine 1 in time. So next column machine 1 out time. So next column is the machine 2 in time. Next is the machine 2 out time. And last column is the completion time. So in the job column, we have to write down the job sequence, that is the J2, J3, J4, J1, J5. So first we have to start the completion time for the job J2, which is the first in the job sequence. So in time for the job J2 on machine 1 is the 0 because it is the first job which is going to the machine 1. So there is the, we are assuming no waiting time. So in time is the 0. And out time is the in time plus processing time. So for the job J2, processing time on machine 1 is the 6 hours. So out time is the 0 plus 6, which is equal to the 6. Next job J2 has to the move machine 2, but up to 6 hours. Job J2 is engaged with the machine 1. So after the 6 hours only, it will be moved to the machine 2. Then in time for the machine 2 of the job J2 is the 6 hours. And out time will become the, so in time plus processing time. So that is the 6 plus 12, which is equal to the 18. And completion time for the job J2 is the 18. So next we have to look for the next job, that is the job J3. So here machine 1 is engaged up to 6 hours with the job J2. So in this regard, job J3 cannot be entered into the machine 1. So it should have to wait up to the 6 hours. So in time for the job J3 on machine 1 is the 6 hours. And out time will become the in time plus processing time. So job J3 on the machine 1 processing time is the 8 hours. So out time is the 6 plus 8, which is equal to the 14. So next to job J3 has to be moved machine 2 after the 14 hours. But machine 2 is engaged up to the 18 hours with the job J2. Then in time for the machine 2 of the job J3 is the 18. And processing time for the job J3 on machine 2 is the 9. Then out time will become the in time 18 plus processing time is the 9. That is the 18 plus 9, which is equal to the 27. And total processing time is the 27. So next we have to look for the next job, that is the job J4. So in time for the machine 1 of the job J4 is the 14, because up to the 14 hours machine 1 is engaged with the job J3. So after the 14 hours only, it will receive the next job, that is the J4. So in time of the job J4 on machine 1 is the 14, and next out time will become the 14 plus processing time. So processing time for the job J4 on machine 1 is the 8. Then out time will become the 14 plus 8, which is equal to the 22. Next, after 22 hours, job J4 has to be moved to the machine 2. But up to the 27 hours, machine 2 is engaged with the previous job, that is the job J3. So after the 27 hours only, it will be receive the job J4. So in time of the job J4 on machine 2 is the 27, and the processing time is the 10 hours. Then out time will become the 27 plus 10, which is equal to the 37. So total completion time of the job J4 is the 37. So next we have to go for the next job, that is the job J1. So here machine 1 is engaged up to the 22 hours with the job J4. Then after the 22 hours only, it will receive the next job, that is the job J1. So in time of the job J1 on machine 1 is the 22, and so job J1 and processing time on machine 1 is the 10 hours. So out time will become the 22 plus 10, which is equal to the 32. So after the 32 hours, job J1 has to be moved on the machine 2. But machine 2 is engaged the jobs up to the 37 hours. So after the 37 hours only, it will receive the next job, that is the J1. So in time of the job J1 on machine 2 is the 37, and the processing time is the 6. So 37 plus 6, which is equal to the 43, and total completion time is the 43. So next we have to look for the last job, that is the J5. So here in time of the job J5 on machine 1 is the 32, because up to the 32 hours machine 1 is engaged the previous job, that is the job J1. So in time of the job J5 on machine 1 is the 32, and processing time for the job J5 on machine 1 is the 12. Then out time will become the 32 plus 12, which is equal to the 42. So here after the 44 hours, job has to move to the machine 2. Here up to the 43 hours only, machine 2 is engaged with the previous job, but up to the 44 hours, job J5 is engaged with the machine 1. So after 44 hours only, it has to be moved to the machine 2. Then in time of the job J5 on machine 2 is the 44, and its processing time is the on the machine 2 is the 5. So out time is the 44 plus 5, which is equal to the 49. Then completion time is the 49. Then total span or total completion time is the 49 hours. So this is the solution, and thank you.